Good morning. It's a pleasure to be here, and it's such an exciting time to be in this field of machine learning and data science because it's gone mainstream, right? I mean, for those of us who've been working on this for 15 years, it's really, really exciting to see that when something like TensorFlow gets released yesterday, everybody talks about it, right? It's mainstream. It's something that everybody's interested in. It's something that everybody understands is where the next step in product and data is going. So what I want to talk about today, though, is about the context and about what happens before that machine learning step and what happens after that machine learning step, and how do we build those products, those data products that we've been hearing about, and how do we put them in context, and how do we make them part of our lives? So thinking about that, as I was thinking about that, I actually remembered that about 10 years ago, there was this video on YouTube that went viral, right? There was a toddler, and they're using a magazine like it was an iPad, and they're panning and swiping and pinching, and nothing happened, right? And so they were just kind of disappointing and threw it aside because it was broken. It didn't work. And she was seen as a generation of what we called digital natives, and people who grew up surrounded by computers, shaped by always-on technology and the internet. And this concept of the digital natives was an entire new way of thinking about what's happening today and how humans are evolving. What I think is happening today is another revolution of that type. We're seeing the rise of the data natives. And data natives are people who expect the world not to just be digital, that's a given, but to be smart and to know them and to seamlessly adapt to their taste and habit. That magazine shouldn't just be interactive. Of course it should be interactive and it should be digital, but it should be personalized and should tell you what you need to know now. Digital natives are comfortable programming their thermostat. That's a given. But data natives expect the thermostat to program itself. In other words, digital natives were concerned with what they can do with technology, and data natives are concerned with what technology can do for them. Data natives don't grow up with a simple baby monitor. They get something called an owlet, which monitors the baby's heart rate, oxygen level, sleep, and the sleep position. And they want the system to automatically learn what's normal and what's not, and to alert you when something is out of ordinary. They don't grow up just watching TV. They expect Netflix to learn what they like and recommend it to them. And they don't just read digital books. They expect them to be personalized and to be interactive. Basically, data natives expect a smarter world. But are we there yet? I don't think we're quite there yet. We're making our way there. And let me give you an interesting example from like a few weeks ago. There was this tweet by our friend DJ Patel, and he's talking about how he's learning some scones tonight at astronomy night with Bill Nye. He's learning some scones? So this is the US Chief Data Scientist with the White House Office of Science and Technology Policy, and Bill Nye is the science guy. And if you Google learning some science, you get 11,000 hits. And if you Google learning some scones, you get 0 hits. So needless to say, there's more than enough evidence that that word should be autocorrected to science. But it's not. Why is that? We're still working our way to making these products smart. We're not quite there yet. So it's on us, data scientists, to bring about that world, right? And to fix that GPS that recommends your restaurant that's 1,000 miles away. And to fix those ads that tell me that I should get my degree online in weeks, instead of, I could have saved like 8 years. It should fix the autocorrect that tells you that we're learning some scones, or that changed LOL into Lollipop oligopolistic. Those of you who work in text mining, what's up with that language model, right? Where have you ever heard of Lollipop oligopolistic? It's not a very frequent bigram. And all of a sudden, around 2009, ducking became very, very popular. And so these are companies who get data, right? And so we're not there. So we take these smart alerts and we press ignore and we roll our eyes. And the expectations are there, but it's still a very difficult problem. So the question is, how do we build this smart world, right? So that's where data products come in. And data products, there's lots of definition floating around, but it's smart context-sensitive software that takes information from you, others in the world, and really enables the other things around you to be smarter and to deliver key insights in the right context and at the right time to help guide your actions. And more often than not, the interfaces are invisible. It's not just about recommendations, here's some stuff you may like, but it's about shaping your life. This is from last week. I have a smart sprinkler controller. And it just emailed me. I didn't have to do anything, but it just gave me a heads up. Hey, we're skipping watering because there's there's some big rain that we're expecting. So it knows about context. It knows that there's rain forecast and how much rain there is being forecast. And it knows that it needs to stop the upcoming watering. Very important. And this is happening everywhere, right? An ecosystem of sensors and streaming data, and it's all promising to make our lives better and richer and easier. And we are seeing an explosion of these network devices. 50 billion of them by 2020, according to Cisco. Gartner says 25 billion, so in that ballpark. McKinsey estimates the economic impact of the Internet of Things, which for better or for worse is what we call these connected things and sensors. It's between 3 and 6 billion. Home Depot now sells 600 smart home products, which is 6 times as many as it did 2 years ago, according to the New York Times. And many of you have a fitness tracker, like the Jawbone Upband, and that's specialized, but when connected, that's where it's very powerful, because it doesn't just track your steps and sleep, but it turns on your lights and your coffee maker and your Nest thermostat when you wake up. And we now have connected door locks and doorbells and smart water heaters and smart desks and garden sensors and drones and satellites and insulin pumps and pacemakers and dogs and light bulbs and exercise equipment and your shirt and baby monitors and onesies and jewelry and alarm clocks and mattresses and thermostats and, of course, cars. Well, that's a lot. Mark Andreessen famously said that software is eating the world, but I think it's actually the world that's eating software. Because you have all of these objects all over the world that have a tiny piece of software they've ingested. And they're all becoming data products and enchanted objects that are eventually building up towards having this immersive environment that's smart and that adapts to you. That's the dream, right? So it's up to us as data scientists to build that world. So before we start building data products, there's a few things that we need to think about as data scientists. We still need to understand our data, and we need core analytics, and we need data exploration. Before building a smart thermostat, you need a thermometer. You need to understand what's going on in your data. So that's the first step, understand your data. Then we need to think about the impact that the data product is going to have. Both from an ethics perspective, is this something that we should do, even though we could do it? but also from more broadly of what impact is that product going to have on your metrics, on your team, on everything else. So let's think about understanding your data some more. This is an example from the wearable space, from Jawbone, where I spent 2 years building and leading the data team. And that's a very interesting data set, right? Because you have the obvious incoming signals, which is centuries of sleep every night, and you have steps and sleep and meals and heart rate readings. So those are just what you immediately think of when you think of wearables and activity trackers. But that's just a start. Because it's a connected devices, you have an app that captures pictures and workouts and team members and social accounts and data for partner apps like Nest and Automatic, which connects to your car and house. And all of that pales when you think of data sets that address the broader context, right? So the example I gave earlier with the sprinkler, it knows about the weather. And so does any connected device, right? It knows about census data. And so does any connected device. That's where the power comes from. And so what that allows you to do is to see global trends at scale. Knowing that somebody slept for 6 hours and woke up 3 times might be useful to them, but you need to put it in context to understand if it's normal or something to worry about. And so you can start playing with data and find interesting patterns, because some of the best data products will have roots informed by these patterns. Let me give you an example. We actually looked at the effect of sleep and its effect on mood. And so it turns out that you need about 8 hours to be at your best mood. So that's wishful thinking, right, for most of us. But it's good to see it coming out so cleanly in the data gathered from everybody. And it's very interesting to see that there's a very natural plateau there that starts around 8 hours. And there's a lot more a lot more stories that are interesting and that are you can find in that data. For example, we looked at how weather affects activity. So it turns out that it does affect activity, but only on weekends and when you're not working. Why is that important for data products? Well, think about it. If you're building a product to recommend somebody to get moving and get moving more, you have a choice about when to intervene and when to tell them, hey, you should go out and move more. But if you're not in a position in which Mother Nature could get you moving, then what chance do we have as a piece of software, right? So then we shouldn't really intervene and tell you that you should get going when you're in the middle of your meeting at work. This is what it means to be context sensitive, right? And there's a lot more like that, right? We noticed that there's this new week resolution effect at the gym. Gym workouts are high on Monday, and then every day of the week they go down, right? So I see a lot of nodding in the audience. Might be a familiar effect to you. And again, this informs data products, and it gives you ideas around data products. You see when people eat and what do they eat, right? So you see that there's actually 2 types of dinners that are happening. There's one at 6 p.m. where what's happening is mostly corn on the cob and stuffing and green beans and gravy, basically Thanksgiving at 6 p.m. Not just that day, but across the year. And then at 9, there's another dinner where you have wine and scallops and oysters and lamb. So that's very interesting, right? So that's actually taking the foods that are overrepresented at a certain time compared to the rest of the day. Then you can look at what candy you like, very relevant for Halloween. What candy do people like depending on their age? Lots of interesting patterns you can mine. Or something that we did while at Jawbone, we realized that these sensors are basically instrumenting the world. So what we've done there is we looked at the effect of an earthquake on people's sleep as a function of the distance from the epicenter. So that was really interesting because it really informs your decisions around how to build these data products to better fit into your lives. Going back to LinkedIn, where I spent the 5 years before that doing data science, to understand your data, you can think about it as a network, and you can think about the underlying structure that's buried in your network, right? So this is one of the famous in-maps of my professional network, where you actually take all of these connections between people, and without knowing anything else, just the metadata, you're able to construct clusters of different people in my lives and where I know them from. And that's actually not using any information that's on their profile, on my profile. It's just about the connections. And this kind of network is found in your data too, I bet. It doesn't have to be about connections, but it can be about anything that's similar to each other, right? So you could take your data and think about the similarity function that you can build between two data points. And once you have that similarity function, you can throw it into an algorithm, like in this case, it was a Barnes-Hut algorithm, and cluster it and see what's the underlying structure in your data. So all of that is before starting to actually build a data product. It's part of understanding your data. And it turns out that if you think about the network, even in the LinkedIn data, you can estimate the probability of a person leaving their job based on the number of people in the network who left. And this is interesting, and this, again, this informs your product and who, for example, you should give new job recommendations. Or, again, thinking about the LinkedIn data, you can actually look at what schools are the most entrepreneurial business schools, right? And you can take one approach, which the Princeton Review takes, and go ask around. Survey-based rankings of business schools. Go ask around, see, who do you think is the best, most entrepreneurial school? So that works. Or you could take a data-driven approach, and you can look at entrepreneurs and see what are the overrepresented schools in their history compared to the overall distribution of schools. So that's how you generate the second ranking. So that's very interesting to see how those two approaches lead to different results. So to understand your data, there are several key ingredients. So from a technical point of view, to even get that good analytics and to be able to explore, you need good instrumentation. You need to log everything as if it's going to be consumed by somebody down the line, and that goes beyond the operational dashboard. Imagine that data is going to go to somebody who needs to pair, for example, an item being shown to the click that went on that item. So I see many cases where actually people don't know what's being shown, and you don't know what click has been paired with that item. And then you can hack it and look at the time of the click and look at what else was being displayed. But good instrumentation is crucial in understanding your data. And the best instrumentation doesn't help unless you have reliable data flow. If you drop events, if your infrastructure is not sufficiently fault tolerant or scalable, you're just looking at the wrong numbers. So for both understanding your data and data products, that's crucial. And of course, you can still look at the wrong numbers and draw the wrong conclusions if your data cleanup is not up to par. And that's something that, that is a theme around data science, where you have to think about data cleanup as a detective, and you have to think about all the possible ways in which your data could be not what you expected, right? So that takes a lot of detective work and a lot of exploration. And you can't do that without fast iteration. Because if it takes 5 functions or 5 pig statements, for those of us who are still using pig, and it takes a half an hour to look at the head of the distribution, we're just not going to do it. We're humans. We're probably going to say, oh, I'm sure it's fine. So you're not even going to realize that one of your mappers is massively lagging because a third of your keys was the empty string, right? So that's a true story, right? But that's not something that you'd realize unless you have this environment where you have this fast iteration. Then, of course, you need a reasonable user interface to do all that. And that includes your programming environment, but also the easy-to-read charts and dashboards, and are not too painful to explore. Then you need context about what else is going on. Maybe the weather, maybe particular holidays. We all been there. So that's how you think about understanding your data. But I also mentioned something earlier, which is solving for impact. What do I mean by that? Well, at Amazon, they famously were using this approach where they write the press release first. I don't know if they're still using that, but that's a good idea. What does that mean? Well, so for new initiatives, you have a product manager, and you start by writing an internal press release announcing the finished product. And you talk about how your current solution failed and how the new product will blow away the existing solutions. Now, if that doesn't sound very interesting and exciting to customers, then maybe it's not that exciting and interesting, and maybe you shouldn't build that. And so then you iterate on that press release, which is much cheaper and much faster than iterating on the actual product. And all of that actually comes from a Quora post by Ian McAllister, who also said that those press releases need to be written in what he calls Oprah speak for mainstream consumer products. What's Oprah speak? Well, you go on Oprah and you explain what your product does, and then she restates it to the audience. And what she says, that's what you want, right? That's what you want to put in your press release to understand if you're actually having an impact, if it's something that's actually moving the needle for people. So another way to think about impact that I found useful was what I used to call thinking about ROI, return on investment. Now, that sounds like very financially focused, right? You think about, usually this is from finance, but it's not about purely the monetary pluses and minuses. It's an entire framework of thinking about cost, and cost includes effort, that includes morale. Is it going to be a product that people are going to be excited to work on, or are they going to see it as just something that drags them down? And this is especially important in a market where data scientists are so hard to find and so hard to keep. What's the opportunity cost? What are you going to leave on the table if you do this and you don't do something else? Of course, the money, but that's the easy one. Are you building up any tech debt? And that actually is all bundled up into your cost of building a data product. Another dimension to thinking about impact is risk. The probability that what you want to build is actually going to ship. Now, a lot of you as data scientists are familiar with this, right? Sometimes you build a prototype and you have this great idea for a data product, and then it never ships. But it's on you to think about the likelihood that it's going to ship and how is that going to look in the end, right? What do you expect out of it? So then you can estimate that probability that it's going to ship, or you can try to think about how can you shape your product so that it avoids the biggest risk, the biggest risk steps. But of course, it's not about avoiding risk and minimizing cost. That's really not what we're here for. We're trying to innovate and build completely new things. So that's why you have to put it in context of impact, right? What is the impact that this product is going to have? And if it's the right impact, then it's worth having a low probability. It's worth having a high cost because it's in its context of really big impact. So what I encourage people to do is, before you start working on a data product, is to think about the likely case and the best case. What's going to happen to your metrics, to the team, to engagement, to monetization, whatever you're optimizing for, if this product succeeds. So think about it before you even start working on it. And once you realize that, hey, this is actually has the potential of having this huge impact, then you're good to go, if you just think about it before you start. So I have an example here where, let's say we have a project that we're trying to evaluate what to do next on. Let's say that we're trying to build an evil empire army. And so we're trying to decide who to add to this team. This is the data product. Like, we're trying to estimate the impact, the cost, the risk, probability that's going to happen. So let's see. Well, we could use a battle droid, and they're pretty cheap, and I'm pretty sure that you can convince them to join, so pretty high probability. But it's not going to do much. The impact is going to be pretty low. You could build a Death Star, and so that's going to cost a lot because it takes a lot of time, and it takes a lot of materials, and it's a Death Star. But it would have a huge impact because it could destroy a whole planet. You could try to get Yoda. He's pretty powerful. He could have a big impact, but and he probably doesn't need that. It's not very expensive because he's pretty modest. But he's probably not going to want to join your evil empire army. So think about the probability that this is actually going to happen before you even try to approach him. Then, of course, you can have think about the Ewok army. That's kind of somewhere in the middle. You can have a stormtrooper or a bunch of clones, and think about how that cost changes as you vary those parameters. Sometimes the sweet spot is taking somebody who's more morally ambiguous, who's a smuggler and who's actually really good and could have a big impact. And so maybe that's the right balance between cost and risk and probability. Or you could shoot for the moon and try to get Palpatine, and he's probably really expensive because he's an emperor and all that. But he's probably going to want to join your evil army. Or you could get Jar Jar Binks. So that's just putting. It's about putting all of this into context and thinking about the impact that your product is going to have. And that's even before you start building the data product. Now, of course, all of this could be completely wrong, right? So, oh yeah. So it could be completely wrong because all of these are estimates, and you might be surprised. So as it turns out, there's some damning evidence out there that Jar Jar is actually one of the most powerful Sith masters. He is actually Darth Binks, and he's an equal partner, if not superior, to Palpatine. So the lesson there is that you could be wrong, and you have to remember to update your priors once the data flows in. So thinking about the key ingredients that you need to build these data products, once you have thought through about the impact and the trade-offs and the cost and the opportunity and the risk, thinking back about thinking of those steps that we mentioned before, and for building data products, the key ingredients are very similar, except the SLAs changed a little bit, or a lot more. If you need good instrumentation to understand your data and analytics, well, for data products, instrumentation needs to be obsessive. It's not enough to pair an impression with a click, but you need to know exactly what else is being shown. What's the order in which it's being shown to account for presentation bias? What are the versions of the algorithm? What are the parameters of the algorithm? What is the string that's actually being seen by the user? All of that needs to be logged. And the consequences of your data flow being broken are much more severe. And it's not just that your weekly dashboard has a blip and you can explain, hey, our systems went down. But it's you losing sales because you're not recommending any items, or somebody's 10-day stepping streak that they worked so hard for is gone. So really strong infrastructure is key. And the data cleanup, well, the moment you're showing data back to the users, you can't afford those mistakes. And you can't have broken UTF-8 encoding And you can't show Darth Vader's LinkedIn account in your people you may know. True story again. And since you can't anticipate all the possible way in which data can be broken, then that's why faster iteration is even more important. And that's where the step that is key to today and in general to what's going on in data products, machine learning comes in, right? So you can get pretty far with heuristics and counts and crowdsourcing, but once you reach that certain point, you need machine learning. And that point, sometimes it comes a little bit later than people accept. You can get pretty far if you're trying to predict when somebody wearing it up was asleep. You can actually get pretty far with predicting last week's sleep time, since we're a creature of habit. But at some point, you need really strong machine learning models. And at that point, you don't want to be worried about which kernel to use in SVM or what smoothing to use for a classifier. Then speed is important. Sometimes data products need to react in real time and respond to user input. And the UX needs to be perfect, near perfect, and robust, because it's being handed to people who are going to misinterpret it and click on the wrong thing. But in this context, user experience is not just about having autocomplete and intuitive interfaces, but also about, in the case that you're building an enterprise product where you have APIs, it's about the interface with your developers. And there's another trend that's going on, which is around invisible or minimalist interfaces. So that's starting to emerge. And of course, you need real-time context. It's not enough to know what the weather is generally like today. You want to have real-time either prediction or readings of, for example, the rain gauge. So if you do all that, then you can start building products like at Jawbone, something that we call smart coaching, where it looks at all your patterns and it tries to give you the right advice at the right time. And it notices all these correlations going on in your data, and it's trying to tell you about them to inform your actions and your decisions. And ultimately, that's what it's about, right? Data science is not about charts and graphs, but it's about deeply personalized experience. Or another one that might be familiar to a lot of you is automatically classifying activities based on the signal that's coming from an accelerometer and also the context. And the context is actually crucial in thinking about activity classification in that sense, right? You are trying to see what people are doing, and that's where the gender, the age, the location, the time of day, the day of week, their past history is actually even more important than the signal that's flowing in. So that's another one where you have to think about the impact and what you should be adding next to have the most impact on your data product. Of course, at LinkedIn, you have recommendations, and you have people recommendations and job recommendations and job matching, and all of those were products that I'm familiar with from my days at LinkedIn. But something that's interesting, and I saw that it's happening again across data products, is actually reflected in the newest data product from Google. I don't know if you saw this, but initially it was an April Fool's joke, but it's now reality. Google Smart Reply, where you actually highlight a few alternatives that you could use to answer your email. So it answers your email for you. Isn't that awesome, right? So there's a blog post that most of you probably read where they're talking about the interesting things that they've seen where they just threw the model in, right? They could see things like too much duplication, right? They asked for the most likely responses, which is natural. And then you have triplets like, how about tomorrow? Want to get together tomorrow? I suggest we meet tomorrow. And so that's not very useful, which is why it's important to not just think about the model performance, but also the context and what metric are you really trying to optimize for. And another bizarre feature that they were talking about in their early prototype was the propensity to respond with, I love you, every time that it wasn't sure. And so it turns out that's what was going on in the training data. That's kind of a default answer. The training users were a very lovable bunch. But that's actually something that we even noticed at LinkedIn, and people you may know, who viewed your profile, and we called it the Obama problem. What happened was that you have this module that says people who viewed your profile also viewed this. And so guess what? Because Obama was a very likely person for people to view, that was just the top result for pretty much everybody. But that's not very useful. It's the equivalent of saying I love you in the emails. So then you have to account for all of those interesting intricacies of the actual data product. So having a great model is very, very important. But then you have to think about what happens before and after the model. And so if you think about these data products and how we're able to use these signals to improve our lives, going from health and well-being to solving big problems around education and food production and food distribution and civic involvement and infrastructure. It's about using data to provide context and personalization, but ultimately it's about achieving your goals. And if we do it right, all of this is behind the scenes. And these personalized experiences are smoothly integrated in your workflow, because the tide, from what I've seen, the tide is now turning towards making data and sophisticated algorithms invisible and making the interfaces invisible. Great user experience and great data are what makes products feel smart. And those are two sides of the same coin, and they actually reinforce each other. And they create a virtual cycle. So on the one hand, easy-to-use software or hardware generates higher volume, better quality data. In the wearable case, if you actually are happy with how it looks and you actually wear it, then you have more data and better quality. And when you log meals in an app, and when you're putting a job title in LinkedIn, it's important to have good and fast autocomplete. And then on the other hand, personalized experiences enabled by data are then big contributors to a product's ease of use, right? So you do want that autocomplete. You do want that to be better, and you want that experience to be smoother. Because as soon as you do that, then your data quality goes up, and your data quantity goes up. And you have this virtuous cycle of reinforcing behavior that makes your products feel smart. And this lets you get the job done, and in the process, it generates a lot more data and a lot better quality data. And all of this is exactly what makes the user interaction feel smooth and smart. And it's really important that we keep users in the loop, right? And that's something that we've seen over and over, and you have to do it in a very unobtrusive way. But what we've seen now is that keeping the user in a loop is not even a loop, it's actually a knot. The user is so tightly integrated in these products that are smart and personalized that it's actually part of their everyday experience. And to support this virtual cycle, you need the right technology. So you need reliable data flows, and you do need the fast iteration, and you need those tight feedback loops. But above all, to keep the human in the loop, you need those data natives. Thank you. So I think we have plenty of time for Q&A.
We have the mics around with the volunteers. So please raise your hands if you have a question, and I'll walk around.
Thank you. Data cleanup is a big effort. If you work in a big environment of sensors, for example, in Internet of Everything related to some complex environment, I see methodologically difficulties to find a unique way to make a cleanup of data because they are so different, the sensor. And what is my principal worries is that many times the provider of sensors don't give the systematic error of their tool. For example, there is a company, I don't say the name, that in a show in Berlin was not able to say is a tool to make the measurement of blood pressure, how much error each measures could have. This is very dangerous. Okay, so how do you think, in your experience, that could be a good methodological approach to solve this huge amount of problems? Thank you very much.
Okay, so let me restate the question a little bit. Data cleanup for sensors is hard. How do we do it? It's true, right? Sensors are all over the place. Sometimes they could be faulty. So it's not only about the manufacturer not exactly knowing how the sensor might behave in real life or what the errors are, but it's also about the sensors being faulty and that not being detected in time. And it's true that it's different from sensor to sensor. And I think that's where a lot of the value add of data scientists comes in, right? So I don't think you can really skip that step. That step of detective work and looking at actual real data points and looking at distributions and understanding what should be normal and understanding how your use case is different from what the manufacturer is actually testing their sensors with. I see that a lot, right? You have some quoted battery life, but then your actual usage is completely different in your own product. So you have to account for that. So I think that's where data scientists themselves add a lot of value because you can come in and you can look at actual data and look at the top of the distribution, understand what are the most common values, and right away, most of the time, I guarantee you, if you do this with your data, you look at your top 10 most common values, you're gonna see something you're surprised about, right? You wouldn't realize that, hey, I didn't realize that we actually have a lot of NAs in what's supposed to be a numerical field. Or if you break it down by a particular value, you might realize that, hey, actually, this doesn't look right. Something is wonky at these extremes of those readings. And that's actually messing up my model. That's something we do every day, but I don't think you can skip that step or necessarily generalize it from a data set to another. You can have these steps that you go through, right, as a data scientist that I just mentioned, looking at the top of the distribution, looking at the overall distribution, looking at individual data points, summary statistics, of course. But overall, that's something where data scientists do add value, and that's why a lot of us still have jobs.
Okay. So regarding the security, what about the security? Regarding, we need to consider some security while doing the data science.
I'm sorry,
security.
Yes, security. What's the question about security? Data science and security? Or?
Yeah.
I mean, it's important, right? So a lot of it's a little bit different than data scientists because it has this adversarial dynamics. But you actually can find those adversarial dynamics inadvertently for regular data products when people are actually using it in ways that they weren't intended for, right? So you see a little bit of that in regular data products. But it's much more interesting to look at what happens when you have these adversarial dynamics and you have algorithms and people battling each other out in the security field. And so that's something where you do need data scientists, and that's something where it's even more important to understand anomalies and to have robust algorithms for anomaly detection. That's when it's important to pool resources from different companies to understand what what is going on in that threat, in the threat models. So that's something that is really important in the data science space. And I know a lot of companies do have teams dedicated to security, dedicated data science team dedicated to security. Do you have a different question that's a little bit more specific about it? Okay.
Okay, I have a quick question. As data science, you usually can want to show the customers the exciting graph and the great performance and the result. But sometimes you will feel the gap because customers don't understand, for example, statistics, don't understand the graph you show. So what's your tips for storytelling the stories and the analysis to the customers?
Yeah, so what's the importance of storytelling with data? That's kind of the gist of the question. I think it's crucial, and it's not just about customers, but it's also about the executives that you're presenting to, and it's about your daily interactions, and it's about your talks that you give. So this kind of storytelling in data and communication is crucial across the board. So you have to develop those skills as a data scientist. So the way I'm thinking about that is to find really interesting aspects of what you discovered. So it could be showcased in a graph, or it could be showcased in a distribution, or who knows what. But what I like to do is focus on one single message or one single discovery that you want people to see, and then take away everything else in that picture or graph or chart, right? So you have to focus on one point, key point that you're trying to show, and everything else has to disappear, right? If you have to zoom in into that particular behavior that you want to see, you want to label your axis in a way that's actually understandable to somebody who's not a domain expert. You want people to understand it without actually having the deep algorithm knowledge. And so if you make it, you have to put it in Oprah speak or USA Today speak. That's something that is a skill that you can develop, and you can develop it by just keeping it super simple and only showing one key point at a time, and kind of developing that arc of, hey, I looked at this and look what I discovered. So then I dug into it a little bit deeper, and then here's what I found after that. And so that's, and then this is how what I found can help you. Here's a few things that you could do with this information. So developing that skill is not easy, and a lot of times us hardcore or computer science people like us, it's easy to dismiss that skill, and it's easy to think about how it's not important and you should just get it. But that's not true. It's crucial. Even if you're talking to technical people, even if they could understand the depth of what you're doing, that doesn't mean that they want to. They have their own things to think about, right? So to simplify the message and to be ready with your answers is important, to be ready with the technical answers, but it's more important to show a simple message or a graph that they could get in a few seconds. So that's my bar. Well, ignore that whole thing with the Star Wars. I walked you through it. But you should be able to get it in a few seconds, right? If that's not true, time to iterate on it's a little bit more.
So I have a few points. It seems that a large part of what you said is that context matters. Okay, that was one point. And the second point was, could you talk a little bit about explaining the results of a prediction of a score? Because in many cases, just producing a score is not good enough, like typically in credit scoring, for example. You cannot decline somebody without telling them why you're doing that. And the last part is that sometimes you have to be careful with your results. I'm thinking about the result about what schools are more entrepreneurial. I noticed that the top were Stanford, MIT, and Harvard. I would say probably it's not the score that is entrepreneurial, it's the people that apply to the school were already entrepreneurial? Thank you.
Yeah, so there's several things going on there. One of them is explainability of your models, depending on your application. So it's true that sometimes you have to make trade-offs around accuracy in order to have better explainability. And that's fine, because what you're thinking about overall is not just a piece of the model. You're thinking about the overall data products and the impact that it has as a data product. And if explainability is part of that metric of impact, then you have to make peace with the fact that the model might not be just as accurate. So, and finding a way to communicate those reasons in a way that's customer friendly, that's not offensive, that takes into account the fact that at the other end of the algorithm there's a human. Those are things that you have to take into account as a product person. And sometimes you as the data person can anticipate those kind of things before a product manager could even anticipate that. So for example, when I was working at LinkedIn on recommending groups to people, I could see that there are some groups that were recommended that could be considered offensive, right? So, somebody working at Oracle would get the group recommendation, Oracle sucks. Not that great, right? If you do a simple string matching, that's the kind of thing you run into. So keeping in mind explainability and the fact that there's a human the other side of a data product is crucial. Your other question is around bias and how there's bias in your data and there's bias in your user population and so on. And my answer to that is to make peace with it because sometimes it's a reflection of who your customer pool is. And you can actually, if you run the right A/B tests, you can eliminate a lot of that bias and see where the impact actually lies, right? So you can actually break it down in several different segments and see why a particular experiment affects a particular population more than another. And to your point about the rankings, and maybe you have some hidden things that you never are able to measure, that's true. And so that's something that we always have to keep in mind and have those caveats ready if we're being asked. Because generally we have to communicate in a simple fashion and then have all of those caveats available for people to understand what are the limitations of the methodology, what are the limitations of what you're trying to do. That's why I recommend to data scientists to simplify their message, because if you don't, somebody else will. And you might not like what they do. You simplify your message, and if you have all of these caveats and you tell, for example, the press or something, you tell them this very complex story, they're going to take away what they want to take away. But if you simplify it for them, then you can shape that message a little bit better. And looks like I'm out of time.
Thank you.